So welcome everyone to our CCNA1 second cohort meeting. A couple things I want to do. First off, open up the floor for any questions you may have right now about the class or where we're at. We've gone through and been talking about module 11 and talking about subnetting and how to use the magic number item for subnetting. We're going to talk about Blsm today. In particular, we're going to look at how with variable length subnet masking, we don't need to have all of our subnets the same size. So again, you see here, one of the things we're going to talk about will be using different lengths to match the different links so that we're not wasting addresses when we subnet. Are there any questions before we get started on variable length subnet masking? Any questions about anything going on with class, any problems or issues? Everyone knows you've been also taking the module exams. Don't forget that each one of these, there are module exams. So make sure you're taking the module exams. They are listed in the syllabus as being due. Make sure you're taking those. Last week, I had caught up on grading. I'm sure I'm behind again now because I don't get, this new system doesn't do a good job of telling you when things have been turned in. So I've got to go back through all of the different assignments and actually grade them. It's one thing I will show you a little bit as we get further into our second course. We will start looking at not just how the content or what the content is, but we'll start looking at how you as an instructor have access to be able to do grading and those types of things. Like all of these little uploads, those are not in the class by default. Those were all created by me for our class. Now I do have a shell I'm going to share with you that you will be able to place into your class, which will make it where you don't have to recreate all these, which will save you a bunch of time. But I need to show you about that and how to do it. But we'll get into that. Right now, we're worried more about the content than we are your ability to manage the class. So let's talk about looking at basic subnetting. If we had this network right here, which had these 4 buildings with the 3 connections between the routers, you would see that you've got a network here or a set of networks with 25 hosts, 20 hosts, 15 hosts, 28 hosts. Well, if we did classful subnetting, which is what we've been talking about to this point, classful subnetting would be all of the subnets have the same subnet mask. If we borrowed 3 bits to give us 8 subnets, which would allow us to be able to handle this network, we would have 8 subnets of 30 hosts. Now that would work with this network, but it's also a big waste because we're wasting on these point-to-point links where there's only 2 hosts. We're wasting 28 addresses that are just part of this /27. Could very easily do it, but it is a definite waste. So what we want to see that we could do, we want to think about, could we have a way to subnet a subnet? In other words, that's exactly what Blsm, variable length subnet masking, is taking a subnet and subnetting it again. So for instance, we've got on this setup here, all /27s works fine. But wouldn't it be nice if instead of doing that, what if we could take it and say, let's decide to subnet? And what they decided to do actually on their subnetting scheme is they said, let's go ahead and leave /27 for all of the buildings, because at 25 hosts, 20 hosts, 15 hosts, and 28 hosts, I would actually leave it at /27, because even though that's 30 hosts, if you've got 20 today, you're going to have 30 tomorrow before you can turn your head around. If you got 28, this building's in trouble, actually, more than likely, because they're going to end up with more hosts than they have IP addresses for. But you'll notice what they decided to do is, instead of using a /27 for these point-to-point links, they went ahead and said, let's subnet that one subnet again. Okay, so we take the /224 or the 224/27 and we subnet it again. Now I'm going to walk out the process here. I'm not going to just, I'll try to do it and show you an easy way to do it. But what we've got here is, this is called a Blsm subnet chart. I'm going to come back to it in just a minute, but I want to bring this out here and I want to bring this over here so that we've got this on this side, whiteboard on this side. Okay, so what we're going to do is we're going to look at a /27 So we got 192. Oops, I'm zoomed way in. Let me zoom back out. So I got 192.20.224/27. Now, what we can do is we can then go and we can subnet that again. So we can go and we can say, instead of using /27, I'm now going to go one more and do /28. Now, what is our variable at /27? Anybody remember? The variable at /25 is 128. The variable at /26 is 64. So the variable at /27 would be 32. So that's what we were subnetting by. Now when we go to /28, our variable is going to be 16, right? Does that make sense? So if we look, let me pull my chart up to make life easier on myself. Okay. So now we're at /27. And so we go to 224 and we want to go to /28. So we're going to take 224 and we're going to break it down. And so this becomes two new subnets, 224 to 239 and 240 to 255. Okay. So we just took a subnet and we subnetted it. That's all we did. Then we can take this 224 network and we can go, I'm going to bring it down here because it's easier for us to work with. So we're going to take 224 to 239, which is /28, right? And we're going to subnet this one again. So we'll go to /29 and our new variable there would be 8, correct? So we go here and we go 224 to 231.
Why would you go not to 232?
Because remember, it's 8 spaces, but look, 224,
Only 7
25,
figures.
26, 27, 28, 29, 30, 31.
Okay.
That's actually 8. So that's why it's 8 spaces, 8 individual spaces. The other side is 232 to 239, which again is 8 spaces. Now, still a little too big. So now we're going to go /30. Our variable becomes 4. And this becomes 224, 227, 228 to 231. And we're going to have to actually subnet this one too, because we need 3 different /30s. And so we're going to here now, and this is 232 to 235, 235, yep. And then 236 to 239. And again, remember, it's 4 spaces. So 35, 36, 37, 38, 39, that's 4 spaces. You'll notice now that we could pull out and we could use 224/30, 228/30, and 232/30, which is exactly what they did in our example here. They went ahead and pulled out those 3 and are using those. Now, what they did though, is they did something a little weird here in that they went ahead and took everything out to /30. What I did was I left this piece right here. I left this. You'll notice is any number from 224 to 239 in this subnet range? The answer is no. None of these overlap with that. So I could actually still use this as a /28 somewhere in my network. And that's where this chart comes in. We have what's called the Blsm chart, especially if you're using it for a anything that's inside of the last octet. You'll notice in our example here, I used, and I'm going to actually see if I can't. Yeah, a little hard to do here. Yeah, I might be able to do it here. So I used the 224, so right here. So I used this. I used this set of addresses. Okay. All right. Actually, I didn't use these. I used this set. Let me change this. Okay. I actually used 224 to 239, didn't I? And down here. So I actually used this set right here. Which means I can't use this /26. So I can't go all the way back up to /26. So this is unusable now. This is unusable. This, it cannot be applied anywhere. And this cannot be applied anywhere because those numbers overlap. But there's no reason I can't pull. You can see right here, there's absolutely no reason that I can't use this on another part of my network with a /28 mask because it is not part of the subnets I've used. So with VLSM, you can pick and choose the pieces that you want to use in your network. The way we typically do this is the following. We typically, okay, so we'll have a network. And let me get rid of all this stuff here. So let's say we have a network, and on this network, we need, all right, so we got a router here, a router here. We got a connection here. We got two Ethernet networks. Go away. There, I did it again. Sometimes the auto shapes are not my friend. All right, and let's say that I need 100 hosts on this side, and I need 30 hosts on this side. Now, it's an unspoken rule. How many hosts do I need right here? Anybody? It's a point-to-point link. How many hosts do I need?
You don't need any, do you?
Well, you got to have two.
Well, I mean,
you got to have an IP address here, and you got to have an IP address here.
okay, but I'm thinking switch and not host.
Host IP addresses. How's that?
Okay.
Host IP.
Okay, yeah, two host IP addresses.
Okay. Now I will tell you, there is a way. It's called IP unnumbered. There is a way to actually borrow IP addresses from inside of here, way outside of this class. But if you ever run into it and you say that Kelly Cottle was a liar, I'm not lying to you. I just don't teach that to this level because it's not something that applies. Okay. So let's imagine that we've got the network 192.168.12.0/24, and we want to support this network. What you typically do is you look and find what your largest number of hosts is. This is how the curriculum teaches it. So if I need 100 hosts, I need to leave at least how many host bits? At least 7 host bits, right? Because you can see right here, that gives you 128 hosts, 126 usable hosts. So if I need to leave 7 host bits to get 100 hosts, that means I can only borrow 1 bit. So that would be a /25. And we know our variable at /25 is 128. So we go break this to 0, 127, 128 to 255. Okay. So now we could pull one of these two networks out. The curriculum teaches you the following. The curriculum always pulls it from this bottom. Golly, I cannot write today. Always pulls it from this bottom subnet. I do not do that. Okay. Your students don't have to do that either. So don't grade them wrong if they pull it out of the bottom subnet. There is nothing at all wrong with saying on this side over here, I'm going to assign the subnet 192.168.12.128/25 because they just pulled this address, this network out of 126 hosts and applied it on this side. What's the first usable IP address in that subnet?
On 192.168.12.128.
Nope. The first usable IP address is
It should be 129.
129.
129 is the first usable.
Because the first and last.
Usable? Right. 128,
254.
what is it, Steve? Or Otisable?
Yeah, 254 would be the last usable.
Okay. Otisable, what is 128?
128 is your initial. That's like equivalent to your 0.
That's your network address. Exactly. That's your network address. All host bits are zeros at 128. And what is 255?
Broadcast.
It's the broadcast, because all the host bits are ones. So we pulled that network out. Okay. Now here's what I want you to see with this chart over here. So we pulled this network out. So since we did that, and I drug it all the way up there, let me drag it back. I'm actually not even sure how I drug it like that. There we go. Okay. All right. So since we did that, here's what's going on. We pulled this portion out, right? So we just pulled this portion out. So that is not usable. And that means everything to the right now is gone. Because if you tried to use any of those subnets over there, they would overlap with the one you've already pulled out. Additionally, you'll notice we can't go back to a /24 because that contains these addresses. However, notice we didn't touch any of this up here. So now we can take this subnet it again. So let's go with a /26. Now our variable is 64. So this becomes 0 to 63, 64 to 127. So now we've got two subnets of 62 usable hosts. I'll go ahead and tell you, real world, I pull out this network right here, the 64, and I put it over here. Okay, because I expect growth. Book world, test world, I'm going to then take this 0 to 63. I'm going to go one more to a /27, which gives me my variable of 32. And we got 0 to 31, 32 to 63. You'll notice now we're over here. We're right there, which gives us 30 usable hosts. And we're going to pull out this network to use. Okay, so over here, this will be 192, 168, 12.32/27. All right. And now we go to our chart and you look, since we pulled this out, we've used this right here. We've used that. So that means none of these addresses are available anymore. Can't use any of those. Okay, so all of those overlap. So that's not usable. Likewise, this contains it. So that's not usable. And likewise, that contains inside of here. So now we can't go back to a /25. But notice we can continue to take this 0 to 31 and subnet it on down all the way down to /30, which is 0 to 3 and 4 to 7. So we could go all the way down and just grab the 0 to 3 and put that right here. So this will be 192, 168, 12.0/30. And the first usable IP address will be .1, last usable will be .2. You'll notice once we do that, so we've used this network right here, so that's no longer usable. That's no longer usable. That's no longer usable, and that's no longer usable. But there's no reason we still couldn't go back and use the /28 at 16, and we could do it for all of those. So I would have done it exactly like this. I would pull this /30 out, put it on this point to point. I would have pulled this /27 here, and then I would have pulled this /25. The curriculum is going to do it like this. The curriculum is going to pull this out, the first one for the biggest subnet that's needed in Blsm, and then it's going to subnet the one below that. The reason that is so heinous is because you end up with these really weird numbers for your point-to-point links. Whereas if we stay low, 0, 4, 8, 12, 16, 30, 20, 24, 28, 32. So they're really simple numbers for us to remember. So variable length subnet masking, you'll notice two things. One, the masks are different per subnet. Okay. You're subnetting a subnet. And one of the things you're going to learn down the road, this is also called classless subnetting. And it's going to be important when we get into routing protocols, because in order to support Blsm, routing protocols have to be able to carry the subnet mask information in the routing protocol updates. Okay, because if they don't, then they assume a classful subnetting scheme, and we don't do that with IPv4 and Blsm. Questions about this? The curriculum uses the very same method. Oh goodness, that's a whole different. That was my lecture from yesterday in my other class. The curriculum uses the very same method. They basically walk through in the videos showing you how to do VLSM and how to take and subnet a subnet. So as long as they're not overlapping, and that's what this chart that I'm showing you is so important for. It shows you where things overlap. So if you pull a piece out of this chart, you need to mark out those other areas that overlap so that you don't accidentally try to use it in another part of your network or on the same router. If you try to use it on the same router, it will tell you this won't work because it overlaps with another network. All right. So that's VLSM in a nutshell, just taking and subnetting based upon the needs for the number of hosts on each subnet. Questions? Let's talk a second about IPv4 network address planning. Okay. First off, hosts are like rabbits. You got 2 today, you'll have 12 tomorrow. So in the real world, I tell people to always plan for at least 50% growth on their networks. It's not always true, but I would always plan for growth. So in the real world, if I was actually doing these examples that we're showing here and doing, trying to do subnetting, I would say that when I subnetted this, I would make it to where that was probably no less than 200 hosts for each building. And then maybe, you know, the point to point, you can leave point to point. That's not a problem, because if it's point to point, you're only going to have 2 hosts. But for each building, I would not have subnetted this for any less than 200 hosts per subnet. And that's just because it's so easy. Do y'all remember RFC 1918? What was RFC 1918? Does anybody remember? RFC 1918. You're at a dinner party, somebody walks up, hey, what's RFC 1918?
Oh, Wi-Fi.
Anybody remember? This is where we specify private IP addresses. Okay. So remember, it gives you the ranges of 10.0.0.0/8, 172.16.0.0 to 172.31.255.255/16, and then you got 192.168.0.0 to 192.168.255.255. And it's actually /16 because you got every one of those networks all the way through. So what I would have done if I was doing this network right here, and that was my example, I would have simply taken the 10 network, and I would have done this. I would have took 10.0.0/30, 10.0.0.4/30, 10.0.0.8/30. That would have given me my 3 across there. And then I would have done 10.0.10.0/224 for one building, 10.0.20 for another building, 10.0.30, and maybe even more. I may actually do 100, 200. Actually, I probably would do 100, 200. And then, or 100, 150. And then let me change this. I got 4 buildings, 100, 150, 200, 0/30, and then 10.0.250.0/30. Excuse me, Tad, 24, not 30, 24. And then that way, every one of the buildings would have had up to 254 hosts. Plus, I would have at least 49 more /24s that I could assign to that building and make it to where it would be expandable. So when we actually get into the real world and we start subnetting things out, we make it simple for ourselves. We take these private IP addresses and we subnet them on fairly easy boundaries. Great example is the building I'm in. This building's 10.102.0.0/16. So on our campus, our building is 10, and I actually showed an example of this, and I may still have it. Oop, I don't. But on our campus, we've got a central point, and then every building is its own So 10.102.0.0/16. Everything in this building is a 10.102.0.0 IP address. The other buildings may be 10.103.0.0/16. Now the beauty of this is, or 10.104, the beauty of doing it like this is it allows us to, when we actually advertise routes to our core, you know, if I've got 30 classrooms in here, so I've got 10.102.1.0/24, 2.0/24, 3, all the way up, okay? Instead of having to advertise 30 routes into the core, I can do what's called summarization and advertise a single route into the core. That is way above CCNA level knowledge, but it's the kind of thing that you need to learn to do eventually when you start to put IP addresses and IP addressing schemes together out in the real world. You try to make it to where they can be summarized to make your routing as simple as possible for your routing devices. Does that make sense? And are there any questions on that? No questions at all? That scares me. All right, let's talk about IPv6 then. Are y'all ready to go to IPv6, or are y'all so far behind you need me to just stop here and let you catch up a little bit? You can be honest. I'm not offended either way, because I won't have time to do this entire lecture on IPv6. Let's just call it. Let's call it. Let's stop. I think everybody's overwhelmed. Opinions. I think it'd be good for us to start on IPv6 next week. Any questions on that? Is that okay with everyone?
No, it's okay.
Okay. I think, how many of you are up to chapter 12?
I'm not there yet.
Okay. Okay. Let's hold off then. Let's hold off. Let's stop right there. Let you work on your IPv4 addressing stuff. Get caught up this week. Remember, I do have a lab session every Thursday, and that's being posted on the YouTube channel if you want to watch it. It's totally optional. You don't have to, but it's there if you want to. And also, like I said, Uzma, I would have gladly met with you in person, one-on-one. In fact, I tried to get in your lab. You had scheduled a lab, but for some reason I couldn't get in there with you at the same time. So if you're really having an issue with a lab, I can schedule a time with you so that we can both be in the lab at the same time and go through the lab together. So just let me know if that's something you need. I will definitely do that. And we'll try to work through things. So let's stop sharing here. And I'm going to stop recording.